So shall we start?
Yeah, start.
On. Good morning. Start. Karo. I'm sorry for the delay. A very good morning to all of you. We welcome you here for the National Space Day celebration from organized by the FOSSEE Project IIT Bombay. My name is Mohammad Qasim. I'm the National Coordinator for the Geospatial Information System division of the FOSSEE Project. So we are really sorry for the delay, and we will start the session right away. In today's activity, we will have our principal investigator, Professor Kannan Moudgalya, delivering the keynote address. Followed by him, we will have Professor Pennan Chinnaswamy, the co-principal investigator of the FOSSEE project, delivering a detailed session about the FOSSEE's efforts towards nation's development, particularly related to the geospatial technology. After that, I'll make a short presentation about the various opportunities that the colleges, universities, and schools across India can have in association with the FOSSEE project, followed by Mr. Rajesh Koshalkar, the national coordinator, the senior manager of the open source hardware team, talking about the space-oriented IoT initiatives that we have here from the FOSSEE project IIT Bombay. And in fact, today, last year, the same day today, our India's mission to Moon, Chandrayaan-3, had successfully landed in the south pole of Moon. So it is the biggest achievement to humanity. And in order to celebrate the spirit of progress that India has, we are having this event today. So without taking much of your time, I would now request our principal investigator, Professor Kannan Moudgalya, to deliver the keynote address. So over to you.
Qasim, how many people are attending? You have any idea?
1700 now, sir. YouTube, many people are joining. Zoom, I think people have received the link late, so they will be joining in some time.
Okay. Good morning, everybody. Really delighted to address you all on this important day. And we should be proud of the reason why this is called the Space Day, National Space Day, because in fact, I was listening to Dr. Somnath just a while ago. It was a 1.5 hour interview. It's an amazing thing. Can you all hear me? Okay.
Yes, sir. So you can continue. We are
Okay.
making it full screen.
Okay, fair enough. So, so I wanted to talk about some of the amazing things that our country has done. In fact, I have a few. I was not planning to present any slides, but I thought I will show some slides that we should be proud of. So, okay, there you are. Okay, good. So let me share my screen. Okay. So I would like to begin with this cartoon. This is a famous or infamous New York Times cartoon. India just succeeded in sending a satellite to Mars. And you see this India here, knock, knock, trying to enter the elite space club. Okay. And of course, this was objected by many people, in fact, including international agencies. Okay, this is not what I wanted to talk about. When I went for higher studies, there were TV stations overseas. There were TV stations that were talking about, should India even be spending money, wasting money on rockets and stuff like that when people are poor and so on. So the answer to that is here, Cyclone Varda, which happened in December 2016. And this is an article from, we are trying to get this, there it is. Cyclone Varda, ISRO satellite saved 10,000 lives in Tamil Nadu, right? Let me make this smaller. Yeah. 10,000. So this was dated December 17, 2016. Basically, it said that the satellite warned that there is going to be a cyclone. Please move to safer places. So here it clearly says satellite saved 10,000 lives. So should we not have invested money in satellite technology? The answer is a resounding yes, right? So let me go back. It is not just to save people, but we are doing cutting edge as well. Chandrayaan-1 finds water on moon. Okay, India's first. And who says this? Guardian, right? Chandrayaan-2 mission is cheaper than the Hollywood film Interstellar. Times of India is taking a little more time to load. There it is. And Chandrayaan-3 mission is cheaper than the Bollywood film Adipurush. Okay. We move on to the next. And Mangalyaan mission is cheaper than the movie Gravity, and BBC calls it thrilling. Okay. So for BBC to say this, because very often BBC is critical of what we have done, but here it is so cheap and thrilling. Okay. And one of the reasons why we have achieved this, all of this, is of course commitment. As I was talking about Dr. Somnath's interview this morning, it's an amazing one. You should all see it. And use of technology, simulation, and this is also an Economic Times article, which actually talks about, why it is making sure that we spend carefully, and so on and so forth. Okay. So I would say being good in technology is essential. I want to, spend a little bit of time on, what is it we do at IIT Bombay to promote technology. In fact, I would like to begin with Dr. Abdul Kalam's quote. Okay. So this is what Dr. Abdul Kalam says. I hope you can read this. Says the most unfortunate thing is that India still seems to believe in proprietary solutions. Further spread of IT, which is influencing the daily life of individuals, would have a devastating effect on the lives of society due to any small shift in the business practice involving these proprietary solutions. It is precisely for these reasons open source software need to be built, which would be cost effective for the entire society. In India, open source code software will have to come and stay in a big way for the benefit of our billion people. This is what Dr. Abdul Kalam told. So I would like to begin with that. I would want to let me just give a couple of examples. I'm not sure why this is. Okay, at least let me keep it here like this. So, yeah. So let me go to page 44. Okay. So that quote of Dr. Abdul Kalam was from our FOSSEE page. FOSSEE stands for Free and Open Source Software for Education. And in fact, I would like to begin with OpenFOAM because Dr. Abdul Kalam comes in this once again. Dr. Abdul Kalam was denied wind tunnel testing of Agni missile. This was before he became the president. He found that CFD stands for computational fluid dynamics. Computational fluid dynamics could also do it. But in order to, basically a lot of computations, a lot of simulations, supercomputers were also denied. Professor Deshpande of IISc improved the algorithm to work 10 times faster, and ordinary computers became sufficient. So Dr. Kalam validated, and Agni missile was successful. He became known as the missile man. Of course, OpenFOAM is a software to do computational fluid dynamics. It is used extensively by BARC, ISRO, and DRDO labs. Recall what Dr. Kalam said, we have to be self-reliant. So we cannot depend on commercial software, that too supplied by, let's say, overseas-based organizations. So OpenFOAM is used in a big way in these organizations, and the FOSSEE project promotes OpenFOAM. These are some of the amazing graphics created by OpenFOAM. Okay, there are some case studies done by students, testimonial by somebody who helped us, who contributed, who benefited. Okay, and then let me just go to next one, which is about Scilab. Because I told Kasim that I won't take more than 10 minutes to talk about. So let me talk about Scilab. Why Scilab? Because our project, the FOSSEE project, was funded by, has been funded by NMEICT, National Mission on Education through ICT. And in one of the early meetings, the founder of the person who started this NMEICT, Mr. N.K. Sinha, he had a meeting, and there were people from various organizations, various institutions, and who were interested in doing projects for NMEICT. And one of the first things that Mr. Sinha asked was, please tell me how you would use Scilab to calculate the trajectory of a rocket that will land on moon. So I'm talking about 2009. We were talking about the, our space exploration, the trajectory of our space mission, and things like that. And Mr. Sinha precisely talked about Scilab. How do you do that? And I will just say a few words about Scilab, and then I will hand over to Kasim. Scilab is an amazing free and open source software. And it's a great substitute for MATLAB. It's about 95% compatible with Scilab. And XCOS is a good alternative to Simulink. So let me go to the next page. It has excellent computational environment. It has LinPack, IcePack, LawPack. These are all heavy-duty computing engines. How reliable is Scilab? Okay, once again, I will give example with CNES. CNES is a French aerospace organization that launches Ariane rockets. Several of our rockets, especially several of our satellites, especially heavy-duty satellites, were launched by Ariane from French Guiana in February, from French Guiana. But here is one about GSAT-31. So let's go here. You can see that GSAT-31 satellite launched from French Guiana, and it is through Ariane rocket. CNES relies on Scilab for many critical calculations. So in other words, our satellite is launched by Ariane, and Ariane is launched by CNES, and CNES uses Scilab. Possibly we are communicating to each other through such a satellite launched by Ariane, which is launched by CNES. And here is a talk by T. Martin of CNES on Scilab. Okay. So he was a senior manager in CNES. CNES is French ISRO. And then, so how do I know about it? Because I was a keynote speaker in this Scilab Tech 2009, where Martin talked. And in fact, I chaired his session. And what does he say? He says Scilab is widely used in CNES, various engineering fields such as telecommunications, RF analysis, navigation, attitude control systems, so on and so forth. Amazing things. And then he talks about how they developed a software to work with Scilab. So I'm just going to skip all this and go to the last page. He says Scilab is widely used within CNES flight dynamics departments. Okay, so that's why it is extremely important. And so if it is good enough for CNES, if it is good enough for launching Ariane rockets, it is good enough for placing our GSAT satellite. If it is good enough for our communication, is it not good enough for our calculations, fast Fourier transform, plotting, and various other activities, right? In fact, there is, I think, one other slide, and then after that, I'll stop. For examples, okay, I'm going to skip this. Okay, I think I don't have that slide. Let me just talk about that Martin's example. We launched a FOSSEE optimization toolbox using on Scilab, and CNES, in fact, Mr. Martin contacted us and said whether we can share that source code with them so that they will be using our FOSSEE optimization toolbox that we created for Scilab. Okay. And so with that, I think I'm going to stop here. I've given enough examples. Okay. There is one other thing I'll show you, and then I'll stop there so that my talk is does not end abruptly. So let's go to the FOSSEE webpage. In the FOSSEE webpage, we have all the amazing software that we are promoting, whether it is Scilab, Python, eSIM, OSDAG, DWSIM, OpenFOAM. OpenFOAM, I spent quite a bit of time. Scilab, I spent quite a bit of time. And many other things, Open Modelica, PLC, Arduino, maybe some of it will be covered in by speakers subsequently. We have R, maybe some of it will be covered. R is an amazing statistics software alternative to SPSS, for example. GIS, I'm sure that it is going to be covered quite a bit. Animation software, and then scientific For science topics, we have SOL. So we have many amazing things. These are done through FOSSEE, and it's fossee.in. It's very easy, FOSSE.in. It'll take you there, and through that, you can actually explore various things that we have been doing. So with that, I think I will end my talk, because faculty members are used to talking for 1 hour, and this celebration itself is only 2 hours, if I'm not mistaken. So I'm going to stop here. Thank you, everybody, for joining. If there are any quick questions, I'll be happy to answer them. Okay, so maybe we are not geared up to ask questions. Kasim, over to you.
Yeah, thank you, sir. So now I welcome Professor Pennant Chinnaswamy, the co-principal principal investigator of the FOSSEE project, to deliver his presentation on this National Space Day.
Yeah. Good morning, everyone. Those who are present in person, those who are present online, a warm welcome to IIT Bombay and FOSSEE's project on promoting this National Space Day. I welcome all of you wholeheartedly, along with Professor Kannan Moudgallia. So today in my talk, what we'll be discussing is where does this lie importance for us as an Indian citizen, and how does it build national capacity in space through FOSSEE and the work that we do at IIT Bombay. So everyone knows that India is growing in a very fast pace, and it is a long due for us. The Indian government is supporting a lot to promote economic growth, and there's a lot of verticals that we're working on. However, unlike other countries, there is an impetus on us to do it more sustainably. When I say sustainably, you can see the sustainable goals on the left, and what you see is almost all sustainable goals have to be managed properly so that our growth is sustainable. So these two are linked together. Our economy has to grow. Yeah. Okay. Second. Yes, swap this. Okay. This is okay. Okay, sorry about that. And so what happens is, if our growth is not sustainable, then we will crumble down to what we started before. This is what other countries did not do. And right now we are looking at climate change, global warming, and all those other negative impacts because of unsustainable growth. So we are pushed to do it more sustainably. We would like to be the forerunner to show the world how we do it sustainably. And for that, we are accounting all the sustainable goals that are required for our economic growth. However, there is a lot of data that is need to manage these properly, and also to monitor what we do. So here is where proxy data can help. So if you look at this, a small image that you see, you have a nightlight image taken from India 2012 and then 2016. If I throw a question on what does this mean to a general public, they will say, sir, there is more houses coming up, there is more cities growing, and small cities are becoming big, etc. So they're showing urbanization and all. However, if you zoom in and see more closely, you will see that the dots are connected through lines. More villages are getting electrification, access to power supply, and also the rural schemes that are helping bringing power and water to the villages are sustainable. So you'll also see the roads that are connecting these dots, which is a function of the schemes by the government on bringing the Gati Shakti program, for example, bringing the villages closer to urban and vice versa. Okay, so so we also see that it's not only for the development scenario, we can also use it for issues such as floods. In the top right, you can see that before and after the floods, how the river wakes up and changes the course. And these cannot be done using normal sensors or other observation networks because these are at a larger scale. Think about managing and looking at the Brahmaputra river, how the river has changed pre and post flood. These cannot be managed because their houses are being washed. And as I said, groundwater is a very important source for development. India has become a food exporter from a food importer, mostly because of access to groundwater. And groundwater has been depleting in a considerable phase. So to understand that, satellites can help. And you can see that how a satellite image can be used for understanding the groundwater change in Gujarat. And all the climate change scenarios and other issues regarding sea level rise, wetland inundation only can be done using an image that is taken from a far away. So in this understanding, we see that there is a lot of images that can come and a lot of remote sensing applications that can be built using satellites. So when people ask what is the National Space Day, it's not only sending our rockets and satellites to the space, but also using the technology. Right now, the capacity is still untapped, and through the FOSSEE spoken and our programs at Rudra, we are pushing more QGIS applications driven by satellite data. And India is becoming one of the forerunners of bringing these satellites to the space. We still are lagging behind in using them for productivity in our own sense. And that is where the Mapathon idea that we have done using FOSSEE's team comes up. So you can see that there is plethora of data. There is satellites, all these are Indian satellites. And you could see that the resolution ranges from 1 meter by 1 meter to 1 kilometer grids. And it can range anywhere from water, rainfall, and then land use, land cover, agriculture, crops, droughts, floods. You just name it, we can do it using satellites. So how do we focus on these? Let's take a small problem statement. There is no water, and mostly groundwater is dry in some regions during the summer. So we need data to understand it. Unfortunately, data is also expensive. So the motto of this program is using open source software and open source data to solve these issues. So what we try to do is we bring all the data together in our program. And one of the key data that we have is our remote sensing data, satellites, drones, etc. And of these, the most important is the ones that we have in space. So if you collect a lot of data, analyze it well, then we can do a better understanding of the problem and give a solution for groundwater issues and other things. So this is a dynamic and cyclic process because satellites are always there. The space technology is always there. How do you use it along with other resources to manage our data and applications is key. So we are trying to do that in this program, and I'll show you some examples. So these are the multiple data that come into the system, and we are celebrating the Space Day, which is highly linked to the satellite data sets. Drones are very expensive, even to fly and collect data, whereas satellites are continuously taking data. There are some data that are taken every day, like very, very high resolution, and some are taken every 16 days, 10 days. I think 10, 16 days are still good for our own applications. And then bringing all them together, we had this first idea, Mapathon. As we celebrate the Space Day, we showcase what can be done through our activities, includes space technology, which is data from the space, and local capacity building through open source software, FOSSEE. So this program was highly popularized by the Honorable Prime Minister of India. in his Twitter channel and also the PMO's office, just asking them, come, let's map India together and bring more attributes and data sets for sustainable development. So with this idea, we have had successful mapathons, and still it is continuing as one of the world's largest mapathon. So an idea that spurred in our classrooms in IIT Bombay has now been celebrated as the world's largest mapping event, which is a big testimony to the work that we do here at FOSSEE, Rudra, and IIT Bombay. So you could see that multiple scenarios have happened. And this is the current mapathon where the registration statistics is going to beat the previous years. Already 10,000 students have registered. Think about 10,000 people using the space data, which is satellite data, and then mapping India. It could be any maps. It could be land use, land cover. It could be your forest cover. It could be water resources, anything. But all of them is linked to the sustainable development of India, the goal that we have. So for those newly joining and understanding the concept of what we do, data for development is very much needed. However, data has its own price. There is a cost for data. There are a lot of data gaps and representativeness, right? Most of us have a water filter at home. How many of we tested the water before buying the water filter? We don't test because it is expensive, or do we periodically test? So certain things like in situ monitoring is very expensive and very local. So to get a broader perspective, we need higher resolution data. So remote sensing is very much used, and of remote sensing satellites, which is the key of space technology. So when a satellite takes an image, how do you convert that to a data that we can use for problem solutions? That is where GIS comes. GIS stands for Geographic Information Systems. And there are paid versus open source software. Again, when we use the paid version, it goes back to the second bullet, which says it is very costly. Almost 1 lakh rupees per year we have to pay for a software. So why not promote open source software through the FOSSEE program? And that is what we are merging the open source domain. We are merging the need statements for India, and we are merging the space technology all together in this platform. A lot of softwares are there. We use QGIS, which is one of the forerunners of very advanced level mapping software, which is free. And this is just an image that we have for understanding how many satellites can be in the future and how many satellites are going to be outdated. So if you see satellites moving away from the Earth, they just neglect them. So once the lifetime of the satellite goes, they just cut it off and it goes out of the orbit. But the idea here is there's going to be many satellites. All of them are going to collect data. What do you do with the data? So space technology is good. Okay, we send the satellites, we send the rockets and all. But then what do you do with it? And that is where we create a program at FOSSEE to build advisories, build solutions using open source software. So the way it goes is you register for a problem, you learn. Sometimes you need to learn the software. If you're using if you're using a paid software to convert to open source software, there is a migration time, there's a learning curve, so we give you time, and the resources are given, as Professor Kannan was showing in spoken tutorials. We have multiple languages dubbed tutorials to learn QGIS, and you create maps using this. You submit the map and you win certificates or prizes. The problem statements are unlimited, so we pick around 10, but choose your own topic is very close to you. It is very personal to you. For example, someone living in the coastal areas can look at how much water inundation is happening, the salinity of the water increasing, and all this can be done using satellites, GIS, and your creativity. So as I said, there are a lot of resources that we created and shared to the world. QGIS tutorials are coming through spoken tutorials, and a lot of data links that we provide, because sometimes finding these data is itself a big issue for students and people who are using it. The boundary data, Kasim has put so much effort to bring Survey of India data to the mapping software what we use. And we created a resource page for people to promote using these satellites. So as a result, this is the first, I always keep the first one very close, because we did not expect 9,000 participants in the first round, and also covering all states and union territories of India, including Lakshadweep, Andaman, Kashmir, etc. So This shows that the power of using open source is tremendous, and satellite is covering all of India. So why not use all the data to map? And a person in Maharashtra would be better to map Maharashtra regions, whereas a person who is situated in Assam can look at Assam's issues and then create maps. So what else did we see is we didn't regulate the age of the participant. So we saw across genders, we saw everyone participate. There was no gender parity, and also age groups. We saw kids participate, old people from retired groups participating, elder youth. Everyone was participating in these 9,000 participants. We also had family teams that participated on a local problem of reduced bees in the garden. So how do you map what type of flowers are there and what type of bees are there? So participation across institutions. We were happy to see doctors participate, lawyers, police people, firemen, including our own civil and other rural development technologies. So across teams, across disciplines, across levels, to manage this, to bridge this, all are driven by satellite data. And private-public partnership also has been established. But we don't stop here. So more satellites are expected to come. You would have seen today they'll be launching a lot of satellites. It can go from any femto satellite, very, very small satellites, to big satellites that are needing a rocket. So these would normally be going through a hot air balloon or something. But please understand that a satellite doesn't mean just going up. It has a sensor. Okay, what this one will capture is temperature, humidity, maybe rainfall. But then what do you do with the data? All these technologies that are built are good, but what do you do? So here in Professor Abdul Kalam's birthday, they were launching a lot of satellites. Almost 100 satellites were launched. So if I go and ask what happened to the 100 satellites data, there is a big question mark, right? So all the effort is there, but why not use that data? Maybe there is less capacity. So we are bringing that capacity and giving an end-to-end solution of satellites, space technology, and end users, linking it to the QGIS world. So the results are very good for us. It is driving our motivation. We have seen a lot of creativity, holistic approach. They are addressing the root causes of the issues. For example, a change in the land use, land cover has impacted insects and bees, which is very, very important for the ecosystem. All these have been done. Proactive management has been done. Maps for regions that had no data. There is no data in Kashmir, but using satellite data, they could establish some data, and real-time problems were addressed. Let's take an example. I've always been proud to show this image, one of the first images, first submission. So this is how a submission looks like. The satellite data is taken. They map where the data is used for. So you can see it was used in Himachal Pradesh region, in a high glacier region, which is not accessible. So if I say, let's put an instrument there, who's going to collect the data? How is the data going to be working? It doesn't work well. But if you use a satellite, you can see how the students team from Anna University have mapped the lake extension from 2008, 2013, 2018. So slowly the lake is going big. Is it a good sign? It shows more water, but is it a good sign? No, because it will any day break. And unfortunately, after this submission, after a couple of weeks, it happened. The lake burst. We call lake glacial lake outburst, GLOF, and it burst and washed away all the small villages under the lake. And this is what we also saw in Wayanad, right? So these kind of areas which are not being accessible by humans to go and measure regularly can be done using satellites. Even telemetry doesn't work here. If you say, I am going to put a sensor and then it will relay the data, it won't work as good as satellites because it comes in every 15 days. So with this, the ideas didn't stop. There's some maps on Gati Shakti, how to link cities and villages, and the locust attack, which happened during COVID. You can see how the maps are showing where locust was coming from Africa. It came through Afghanistan and comes into India. We are seeing where it came and how it can impact. All this before even the impact can happen, so the people can take actions. And then here we can see that how the sustainable development goal of zero hunger, where should government invest the red spots to promote food security, all these things can be addressed. So I think I'm almost on time. So I'd like to thank the NMICT for the funding, because they have been very supportive for the FOSSEE program and spoken tutorial. I'd like to thank all the team members, especially Professor Kannan Mudgalia, the PI, and Mr. Mohammad Qasim, the manager who is holding all these together. All the FOSS tools, because people are creating these tools for free. We work it on for free, so we have to thank all the tools that are given, and especially QGIS, data providers, Space Technologies, and all my students from Rudra who are also present here. I'd be happy to thank you and have questions if any. Thank you. Qasim? If there's any questions, let me know. So there are some questions regarding the data that is being used and how to populate the data from your systems for a perspective. Okay, so I would like to go back to how this technology works. So satellites are pushing data into the servers of ISRO, NASA, and other things. We are using mostly Indian satellites. What happens here is you have satellites that are giving data at 16 days or 10 days interval, and resolutions that can be 1 kilometer. We showed that the resolutions can be 1 kilometer and 1 meter. How do you convert that to accessible data? This is a question that everyone has, correct? So these data sets are in numerical digital format. And when it is brought down as pixels, like how you take an image from your camera is all storing it in numbers, right? So satellites also store it in digital numbers. And when they send it to us, you take it and convert it to a raster image or an image that can be put on your GIS software so that you can analyze it properly. So what is the power of GIS? I can see my presentation, sorry. So what we see here is, for example, share screen. Yeah, no? Okay. Oh, here. Oh, window. No? Super window. Okay. Okay, so what we see here is, suppose an image comes. The image cannot be readily used to create these boundaries and data that you see here. There are some steps. So what the student has done is, it's called NDWI. It's an indicator that is made using raster data. So how do I learn? So this is one of the questions that have been put for the GIS community in Mapathon. Some levels of understanding of GIS is needed. Some levels of understanding of what the data tells is needed. So basically, the data is only giving a reflection. What you see is white is snow, blue is water, and then the brown and black are just the rocks, correct? And some green is there. But how does this blue convert to a map that you see down? So why is it blue? It's all pure physics where a reflection happens. by the image, and only the color that it is being there. So water is blue, so only the blue gets reflected back, and it is being captured by the satellite. And this image is then converted with some algorithms using QGIS to NDWI indicators. So normalized difference water is what we are looking at, index. So this NDWI index can be only created in a platform or an algorithm using a modeling tool like QGIS. So you will have to learn it. You cannot just directly use it and bring. So if I use it, you can only look at the boundaries and it's expanding. But this data set that you see, how big it is becoming in area, right? That area you cannot gauge just by an image. So this is where just using a satellite data is not enough. You will need to input it into a software, do some calculations, and then arrive at a solution. And not only this, if you do it very well, the IIT team, FOSSEE team would be happy to help you write this as an article in a journal. And one of our interns that used this data from the Mapathon created a very wonderful paper on the Western Ghats. And the Western Ghats paper was then pitched up to a lot of news channels, and a lot of coverage was there on seeing how soil erosion happens along the Western Ghats. So this intern, Vaishnavi, who worked on this project, was like this, just a Mapathon contestant, and they did some Mapathons. Then they did an internship with us in FOSSEE. So what else do we do at FOSSEE? We don't stop here. We don't stop at Mapathon. We identify talents that have done very good maps. We also mentor them. So my team is here, Manu and Mohan, along with Kasim. So they are all working together to mentor these students to achieve a better solution. So maybe some student only knows to capture the image. They can draw boundaries, but they don't know how to do the index. So our mentor team will have online mentorship with the students to create these maps. So it doesn't stop with just data access and QGIS. There's also a cloud of mentorship that happens where you work with one of the best brains in IIT Bombay to look at how can we create these maps into end results and then publication, right? So many of them struggle to write a publication, but if you have a good work and a good team, then you can quickly write it at a higher pace. And coming back, these kind of events can be also pitched as an early warning system. So if I say that this lake has been expanding every year and there is a threshold, after the threshold, the lake cannot hold the water, it will come out. Satellites can be used as an early warning system. And these satellites has to be mentored at a state level, district level, then given advisories to villages. So what happened here in this image is it is done at a state level, right? But then there is some small districts that are more vulnerable. So you can see highly suitable for the locust to attack. And it is a function of sandy soil, moist soil, open land. So if you know that the soil and the moisture, which is coming from satellites, it can estimate the moisture, then you can tell exactly at what pixel the locust will attack. And it is normally like a hotspot, right? So these boundaries are done, these estimates are done. However, some lag is there after the completion, and that is where the mentors in FOSSEE and Rudra will help you to finish these maps as an end product. And these end products are very important. You can see how the locust attack is changing from July, and then it goes to August, right? And September, October. So the swarm comes in through Jaisalmer and then moves upwards. It moves upwards because the moisture also moves like this. And the moisture movement can be taken only from satellites. Think about your house. How can you put, let's say you have a house village, most of you have been to a village. How can you put a sensor there? And who's going to monitor the sensor? But here, using satellites, you can stay in the comfort of a good internet society, like you can in your classroom or in a campus, download the data and then do it. So one question also which has come is why these participants are spread out? Why can't they be just in one location? Let's say Maharashtra. The beauty of having this is the satellite data can be accessed anywhere in the planet, right? You can sit in Kashmir, you can sit in Tamil Nadu, Chennai, anywhere you can access a satellite. but you can also go out and check if the satellite is correct. Every data has some errors. So we are very aware of the errors. So the person who's sitting at, sorry, who is sitting in Rajasthan is better equipped. Go and check if the data is right or wrong. Because at the end of the day, these are proxy data. You remember my first slide where I was saying it is proxy data. Proxy means it stands for something else. So satellite data was sent to monitor rainfall, but it can also monitor land use, land cover change. It can also monitor the swarm attack, the locust attack, and etc. So still there is less participation from some states and union territories of India, for which we are including multiple programs and schemes to encourage them, especially Kashmir, Assam, and some regions that do not have much numbers. So Mr. Kasim will explain the programs and awards that we give. Again, at a student level, you also need just not problem statements, sir. I'm not only for problem statements or papers. I would like a recognition. And the recognition will be given at once using awards. So we have National GIS Fellow Awards. We have also champions and winners. And all the awards that we give are electronic, e-copy. So you can attach it to your LinkedIn, or you can attach it to your CV. And anytime you access it, it will come up as a page certification saying that in FOSSEE you have done this. And it can help you get jobs like in the past. Some students have got jobs using this. Okay. So think about the potential. And space technology is for everyone. Initially, space was only for aerospace people, people who are sending satellites and stuff. But now the need is more important. Space technology is coming up. A lot of rockets, a lot of satellites are being launched. But more important is what do you use it for and how do you use it for? Who uses it for? So this capacity, we are building it as an open source community in IIT Bombay. And there's a lot of questions also on how do you bridge this interdisciplinary. Sir, I'm a geology person. I do not know about environmental science or remote sensing, which is more civil. No, it's not like that. Remote sensing and satellite is more interdisciplinary. I can give you a lot of examples how satellite data has helped criminology and making of maps, social work. So social work, you want to see where farmers have been marginalized, farmers are pushed away from farm, and females are taking up the farm work. You can clearly map it using satellites. Healthcare, where there are hotspots where there is dengue and other issues can be mapped quickly. And human development. Again, this is more important to have a sustainable growth in India, because the human development is the key for India's development, right? And there is no distinction between the space technology and what we do. There is a lot of technologies that are coming up. And as I said, there should be hand-in-hand interaction between technologies like this, which are sending the satellites, and where do you keep the data? So one aspect that we are creating in IIT Bombay is creating a server to hold all this good data that you collect and then giving it free for others. Thereby, what happens is you will have your links here. I hope you can see in the link at the bottom. We do not take credit. So for example, this work was done for FOSSEE. The prize winner was given a prize money from FOSSEE and an award. However, our name doesn't come on this. Only the person who has made it can come. So we also promote local talent and capacity. Let's say Mohammed Faizan, someone has read this, you're looking at it, some government agency is looking at it online. They can quickly call him or email him using the contact details that are provided. Our emails are not there. Maybe it can come to us saying, Professor Pennant, can you find who made this map? So, but we made it clear that all of you will get traction and the local capacity is built. Again, if someone in Tamil Nadu can do it for a glacier in Himachal, why can't Himachal local people can do this? It's the same technology, same satellites, same GIS. So this is what we want to promote. The capacity is not understood. We are first sensitizing what capacity is there, what can be done by satellite technologies and remote sensing data, and how it can help. Even here, the others, there is a theme, and some people are not willing to share emails, which is fine. But as long as this we promote and we put it on our website, we have people's, here also you can see the name is Tina, and her email has been given. We don't know which location, I know from my data set, but here it doesn't say which location, but anyone can email them saying that, oh, I want this to be done for Maharashtra. I want this to be done for Goa or somewhere else. So this capacity building and bringing your name out is also what we do at our FOSSEE program. And more importantly, there is a mentor also identified. So you can here see Dr. Sheila Sunita Chandorkar is the team mentor. So we don't only promote the students who are doing the work. There is also a assistant professor in the department who we also say, okay, who's your mentor? Let us also acknowledge the mentor. So thereby the college also grows and shows the capacity to do this mapping, because the students will move on. The students will get a job or go to higher studies, whereas the faculty will remain in the university. And this is a Delhi School of Economics, students have done it. So you can see how their name and their department also gets promoted. And all of this we didn't know, right? So initially, why is economics student doing mapping? And then you say, okay, there's a geography department. And then the geography department works with economics to look at sustainable development goals. So all this is done. And one more important thing is we don't distinguish between IITs or any other university. All are equally treated. Okay. So when a problem statement comes, everyone has access to it. But if some student says, sir, my internet is slow, I cannot download the data, my computing facilities are slow, we cannot do it, we help them. We actually download the data, we help them to tell where the data can be accessed and how other tools can be used to collect this data. Some students do not have a mentor. You can see here there is a mentor mentioned at the bottom. Some students do not have a mentor. Maybe the faculties did not have time for this. So we have our own mentors that are doing it. And all this is being covered to have an end-to-end solution from space technology to bringing it into a usable format. So if you look at this map, you can see that, okay, those areas are where the government needs to pitch in for new schemes. So here people are highly affected by food insecurity. There's no food, but here there's good food. Okay, very resistance to food vulnerability. But why not have a scheme between these two regions? Why not have a scheme between the dark green and the red areas? So this is where the impact comes. And at a higher level, no one can understand these, but if you go down to a scale at a satellite level, we can definitely catch these. So right now I will stop with Kasim coming up for telling about the awards. Okay, so there are multiple awards at multiple stages in your assignment. Please, again, all the students who are participating, all the students who want to use these space technologies, please use our notes, our tutorials on accessing this data. And one more question is, do we have all the satellite data available in India? No, we do. We are limited with the bandwidth, so we don't carry all the satellites that you see here, but we have links to all the satellites that provide this data. Okay, so for example, there is NASA satellites, there is European Space Agency ESA, and then there is our own satellites ISRO. So each one is hosted in different websites. We do give them in our links. When you go to the resource pages here and major themes, you will see that in the resources you will find all the data, all the links to the different data sets, and then how governments can partner. So if you see in the previous editions, you saw ISRO was our own partner. And what has helped this? So if someone asks me, sir, how has this helped ISRO? Okay, so ISRO came up and asked the same question, and we did some calculations on seeing just as how much hits have been happened during this window. So the window is from submission was 14 December to 31st December, but 3 months before the Mapathon started. So maybe in September we started it, and they were saying 300% increase. 300% increase in download of data from ISRO, because in this edition we said only data from ISRO satellites should be used. So all the satellite data that you saw that they use for maps in the first Mapathon was purely from ISRO satellites. So here they saw that, okay, if you don't give a solution, if you don't create a capacity to use this satellite data, the number of hits, the number of downloads the ISRO program had was very less. So 300% increase. This is what the numbers they gave us. And they are also partners. But again, as we move on, we have new partners coming. Like here we have Tamil Nadu government, Kerala government is also coming through ICFOS, and then Tirupati, IIT Tirupati is coming. So all these new partners are engaging with us so that we can expand our boundaries to more regions. And one of the reasons you see why Tamil Nadu has a higher participation is because the Tamil Nadu government skill development board is working on bringing registrations up. So with this technologies, I will stop here and hand over to Kasim, who will be explaining more on the data sets that are available, the awards that you are getting through this program. And if you see down, so for example, the Bhuvan website is there. So someone can ask, so if there is already a Bhuvan website, why do you have to have another resource? Sometimes the access to data is limited or it takes more time. And there is no tutorials on on downloading these data in multiple languages. So what is the beauty of spoken tutorials is we have it in multiple languages so that someone staying in a region where English is not predominantly used can be used. So we want all of them to participate in this exercise. You should not be limited by money for a software or language. You need to have all access, and this is what we cover through the system. So with this, I will hand over to, I think most of the questions have been taken. Yes. So I'll hand over to Kasim, who will talk about the champion winners and notable participants and conclude the session. Thank you.
Can you hear me?
Yes, Professor Karan.
I have a quick comment
Yes,
because you said that anybody is welcome to participate. In fact, I would like to point out, I would like to expand on that.
Sure.
We invite from all colleges, all schools, no exceptions. Also, we don't shortlist anybody based on the marks, class rank, and things like that. Because it is possible that there may be somebody who is a lot more interested in satellite technology, and for argument's sake, maybe less interested in, let's say, chemistry. That person may not be doing extremely well in all the subjects, but may have great interest in satellite technology and may be able to contribute. So as a result, our selection is always based on how a student performs in the given task. Are they able to do the work? We're not going to look for your ranks. We're not going to look for your marks, whether you are in a top tier college, not so well-known college. We are not going to look at any of those. Anybody who can deliver is welcome. Okay, thank you, Professor Pennan.
Yeah, thank you, Professor Kanan. As he says, skills are more important here, and maybe this is more liking of your skill, and we do not distinguish between marks. So thank you, Professor Kanan, for telling that. And I'll now hand it over to Kasim to talk about the awards that we have and how students can participate more on different levels as internships, fellowships, and also get mentor support from IIT Bombay. Thank you.
Thank you so much, sir. So I welcome you all again for this National Space Day celebration. I understand that some of the universities and colleges across India had difficulty in receiving the link. My sincere apologies for that. I hope you are able to join comfortably now. In case if there is any difficulty in joining, please be assured we will be sharing the recording of the session to you right away. And before entering into my presentation, I would like to point out that we will be having two other events following this. One is the Teachers' Day celebration. We are going to have it on hybrid mode. And the second event that I want to mention is, in fact, that is going to be a very major event which we will be conducting here at IIT Bombay. That is open for all universities, deemed to be universities, autonomous colleges, affiliated colleges, schools across India. And that is called as Open Source GIS Day Celebration, brought to you by the FOSSEE project here at IIT Bombay. I would sincerely like to thank our principal investigator, Professor Kannan Modgalya, who has given us this opportunity to organize this National Space Day event. I'm thankful to Professor Pennan Chinnaswamy, our co-principal investigator. He is also the professor in charge for the Rural Data Research Analysis, the Rudra Lab here at IIT Bombay. I'm thankful to the spoken tutorial team, again headed by Professor Kannan, who spread awareness about various IT literacy courses. In fact, it is one of the very few award-winning edutech programs that India has witnessed. So I'm very much thankful to the spoken tutorial team for joining us. And our funding agency, the National Mission on Education through ICT, Ministry of Education, Government of India, for the generous support and funding in all of our activities. So welcome back to the National Space Day celebration. We are happy to have all of you. And as far as the registration statistics is concerned, we have around 1,700 teams joining us today virtually. Once again, I would like to sincerely apologize in case if you have received the links very late. Yeah. So this is our core team. I'm from the GIS vertical of the FOSSEE project. Our senior manager, Mrs. Usha Vishwanathan, is here along with us today. I have my colleagues from the Rudra Lab. Excuse me. Mhm. Okay. Yeah. Yeah. Sorry for glitch here. So we were just trying to align with the YouTube live stream that is happening. So I'm from the FOSSEE GIS team, as I told, and on the screen you could see our principal investigators photo, Professor Kannan Modgalya, Professor Pennan Chinnaswamy, who have delivered the session just before me. The name of our funding agency is National Mission on Education through ICT, Ministry of Education, Government of India. And from the FOSSEE project, we basically promote the usage of open source software in academic institutions and industries across India. And to be more specific about the GIS team, we conduct foundational activities going up to activities like job fair, conferences, internship, product development opportunity for students across India. And we heavily promote the usage of QGIS software, as Professor Pennan had pointed out in his presentation. I would like to acknowledge our partners who have been very much helpful in all of our activities from the very beginning. The Rural Data Research Analysis, the Rudra Lab is the cherished partner. In fact, it is the organizing partner from the very beginning in all of our activities. We, in terms of knowledge partners, we have Survey of India. Sincere thanks to them. Professor Mr. Pankaj Mishra, he has been very much instrumental in getting all the shape files officially from Survey of India for the usage of, for our use, for all of our activities here. We are much thankful to Government of Tamil Nadu, the Tamil Nadu Skill Development Corporation, Madam Innocent Divya IAS, and her entire team, who has been instrumental in spreading awareness about our activities in colleges and also among unemployed youths across Tamil Nadu. We are thankful to Government of Maharashtra, the Department of Water Resource Development Department, who has been supportive in all of our efforts. And in fact, even in this year's Mapathon and Geospatial IoT Hackathon, they have come forward in providing the problem statements, and probably in the main internship session with the guidance of Professor Pennan, we will be finalizing the topics which will be assigned to the interns in batch 2. We are thankful to our cherished partner ICFOSS, International Center for Free and Open Source Software, which is an independent body supported by the Department of Electronics and IT, Government of Kerala, who has been much instrumental in all of our efforts. We are much thankful to IIT Tirupati's Navavishkar Innovation Hub Foundation. They are a DST funded entity. In fact, they are funded through a mission called National Mission on Interdisciplinary Cyber Physical Systems. They are specialized in positioning and precision technologies. In fact, Navavishkar iHub Foundation has been a partner for the previous edition of the Mapathon, and we are very much thankful to them. And before continuing to the next slide, I would also like to thank and acknowledge Delhi School of Economics, Delhi Technological University, Dr. Baba Saheb Ambedkar Technological University, Maharashtra, Anna University, for the generous support in terms of more participation from their institutes. Okay, today we are having this National Space Day celebration. Point to be noted is that alongside the Space Day celebration, India is a developing nation, and there are a lot of youngsters who really want to grow along with the nation. So ISRO being a cherished partner, in fact, as far as ISRO is concerned, they are the ones in fact, from the FOSSEE project, the GIS vertical of the FOSSEE project, we promote each and every participating individual and team to use and promote the usage of Indian satellite data, the satellite data which is obtained from ISRO and subsidiaries of ISRO, MOSDAQ, Vedas, and all other portals that ISRO has. For most of you, it might be a new thing, but the point to be noted is from the first edition of our major activity Mapathon, we have consistent participation of a minimum of 9,000 teams, 9,000 participants on an average. And this year, it is the 4th edition of Mapathon that we are conducting. And in fact, we have a participation of around 7,000 individuals as of now. And the registration, the date of registration is open till the last date of submission, which is the 30th of this month, but possibly we will be extending it further. So having this special occasion in mind, that we will be happy to onboard the colleges across India. In fact, the point to be noted is we have institutions which are dedicated to tribal welfare joining us today from Telangana, from Hyderabad. We welcome you. We have colleges from Tripura joining us, from Tripura, Meghalaya, Assam, Jammu and Kashmir. IIT Jammu is joining us today, IIT Guwahati, IIT Mandi. So it is, in fact, a very fortunate thing that we are able to have all of you. The highest number of registration for today's event is from Andhra Pradesh. So Godavari Global University, the registrar, the vice chancellor, and the entire team from Godavari Global University were much thankful to you. And from Karnataka, especially Siddhaganga Institute of Technology from Tumkur, we thank you again for your able participation today. I'm sorry if I have missed any specific institution, and also the colleges which are joining from Delhi University in today's event. Okay, so we have witnessed the session about what FOSSEE is. Professor Kannan had elaboratively given a presentation about what the FOSSEE project is about. Professor Pennan Chinnaswamy has given you an overview of the activity, the geospatial activity, Mapathon kind of thing the activity that we conduct here. But there are a few mandates that we have put for ourselves and also for the participating teams to adhere to. First, anyone who wants to participate in any of our activity, they need to be a citizen of India. Second, they should be they should be from a college which is duly recognized by UGC and AICTE. And in that sense, all of the colleges, like even here we have the presence of Maharashtra College. Much thankful to the principal of Maharashtra College and college from Jogeshwari joining us here personally at the venue. So we are much thankful in this sense. And in fact, I would say that there are two principal mandates that we have. We encourage the teams to follow. One is the usage of open source software. Please only use open source software, specifically QGIS, while participating in any of our geospatial activities. That is a cardinal mandate. The other important mandate is Government of India has enacted two crucial policies. One is the National Geospatial Policy, which was enacted in the year 2022, and the Indian Space Policy enacted in the year 2023. So any submission or any kind of work that we expect from the participants or the work that you're going to submit to us, please make sure that you read the policy completely and adhere to it. And the crux of the National Geospatial Policy is that Indian citizens of India need to be aware of the boundaries that Government of India officially recognizes, which could be easily downloaded from the Survey of India portal. So this is this is one among the core mandates that we have. And in our activity, like every institution is moving towards sustainability, sustainable development goal, and all those things. So even in our activity, when you propose any problem statement, please make sure that it is aligned to at least one of the 17 SDGs, Sustainable Development Goals. And the problem statement should be India specific. Please make sure that you work on real data sets. And there are some product development activities and dashboard development activities which we are having in mind. Probably the winners of IIT Bombay FOSSEE Geospatial Mapathon and IIT Bombay Open Hardware IoT based Geospatial Hackathon, you might be getting a chance to design dashboards and related stuff, including product development. So those will be inclined towards Government of India, our Prime Minister's vision towards having a very strong Gati Shakti interface. As far as the FOSSEE team's activities are concerned, in fact, we have a pyramid of excellence for the geospatial activities. This is actually inspired from Professor Kannan's pyramid of excellence. So what we basically do is, our objective, the objective of the FOSSEE project is basically to promote the usage of open source software across academia and industry, all colleges and also in industry. So from the GIS team, we heavily spread the awareness of QGIS software among colleges and industry. So that we call as the foundational stage. Once we do the promotional aspect of the FOSSEE GIS initiatives, we go one level higher, wherein we conduct competitions. So Mapathon is one of the major competitions that we conduct from the geospatial team of the FOSSEE project. The other activity which is parallelly running now is the national level open hardware IoT based geospatial hackathon. The winners of these events, the winners and champions, we have two different categories of the finalists. They will be eligible to apply for internship and related opportunity with IIT Bombay, the FOSSEE project. And after the internship, in fact, if we find the candidate to be of very good caliber, we will give them another chance of directly associating with our core activities. As Professor Pennan had pointed out, we also have another sequence called National Geospatial Research Fellowship. It is a meritorious tag which only the winners and champions of Mapathon and IoT Hackathon can apply for. Others, there is no open registration for it. Yes. And there is parallelly, we also have created another channel. We call it a special purpose vehicle. So one way of getting into our internship is through Mapathon and IoT Hackathon. We also want active participation from students from the northeastern states of India, Jammu and Kashmir, Ladakh, and Andaman and Nicobar Islands. For this, we have created a special purpose vehicle. Even in case the participation of candidates from these specific states is not up to the mark, we will give them another chance. We will handhold and guide them and make sure that from every state has a proper representation. So that we call as special purpose vehicle. Above all these activities, we also intend to conduct a job fair, a dedicated domain-specific job fair here at IIT Bombay for non-IITians. For students who participate in our activities, we'll try to interact with the companies. We will have a local session here at IIT Bombay or anywhere we plan it in the near future. And above everything, we have something called the Open Source GIS Day celebration. So it will happen on September 15th this year. And in fact, we want it to be a recurring activity that is mainly to appreciate the spirit of open source software, which is actually used by the faculty. Like, we want to celebrate the spirit of open source based teaching learning method in colleges across India. So on like during the Open Source GIS Day, we will be having the National GIS Awards this year. We will also be having a industry academia interaction. We are trying to have it. If we get sufficient number of candidates from the industry and the decision makers, we will have that on the same day. Like this, we have 4 other events planned. So September 15th, please mark your date, write to us. We'll be happy to onboard your institution as such. Okay, so my talk is not going to be more technical. So I'm just giving you the gist of what we do. If your institution is something that you apply to NAAC for accreditation and all those things, all the activities that your institution, your faculty or student, when you participate in our activities, we give you a performance summary, which you can use it for your NAAC and other related documentation. We are making this kind of facility available because all of our activities, the FOSSEE GIS team's activities, they are directly under the National Mission on Education through ICT. So in case like activities ranges from Mapathon, faculty development programs, joint conferences, local gathering for technical interactions, designing of curriculum. If you want any support in terms of introducing open source based curriculum as part of your regular like course offerings, we'll be happy to support. In every kind of interaction that you have with the FOSSEE team, the FOSSEE GIS team, we will be recognizing you with a performance summary. As far as the faculty is concerned, just a while ago I was mentioning about National Geospatial Research Fellowship, a very coveted tag that a limited number of students will get. In the same way, from this year onwards, on September 15th, during the Open Source GIS Day celebration, we will be honoring 1 faculty member per state and per union territory across India for their efforts towards the geospatial technology. So that we call it as National Geospatial Faculty Fellow Award. This is going to be a most coveted thing. And in fact, wherever we participate, if it is going to be a remote event, which is co-organized by the FOSSEE team, we'll be happy to have the faculty fellows representing the FOSSEE project during those main events. And students have a lot of benefits, as I have already told. And in fact, the additional benefit that you can have is, if you are contributing very heavily to the GIS efforts of the FOSSEE project, we will confer you the tag of local campus ambassador. So this is something that we are planning to start very soon. In fact, we want representation from every college and university across India. So this is a short newspaper cutting about Mapathon activity. In fact, in last year's Mapathon, we had participation from around 14 IITs, 15 NITs, 209 state affiliating universities across India. And number of qualified participants after we have received the submission was 5151, more than 5,000. eligible participants were there from various teams. And we are very much sincerely thankful to the faculty mentors who had supported these participants in uploading the submission on our official Moodle interface. Professor Pennan had uh, given you a very in-depth overview of the Mapathon activity. And because more number of colleges are witnessing this event today, in case if you have not registered for the Mapathon activity yet, we request you to scan on this QR code, the QR code which is visible on the screen, or go to the URL which we have mentioned it on the screen. It is http://iitb-mapathon-2024.fossee.in. Please visit our page or scan this QR code to register for this year's Mapathon. There is no harm in trying. This is a very unique opportunity that the FOSSEE GIS team is making available to all of you. As Professor Kannan had pointed out, all of our activities are literally open for everyone. We don't categorize anything. Please feel free to apply. If you need any kind of extra guidance and support, our dedicated team from the Rudra Lab will be organizing a question and answer session wherein we will be able to help you. On the Mapathon's website, we also have given sufficient resources from where you can learn the basics of map making, how to come up with a problem statement, how to upload the evaluation criteria and everything. So please scan this QR code. And as you could see on the screen, our process flow is very streamlined. Once you are done with the registration, we will allow you with sufficient time to learn a software, the open source software QGIS, if you don't have any exposure to it before. Once you are done, we will guide you with slide techniques of creating maps. Tutorials are already available. In fact, the best in class tutorials for learning QGIS software in multiple Indian languages is available on the Spoken Tutorial website. We also have given links to the resources page for the Spoken Tutorial course content. You can obviously have it. Submit the map, wait for the evaluation to be completed, we'll declare the results, and from there you can pick it up. And for this year, it is not mandatory that you have to stick to this, but these are the focus themes for this year: green energy and sustainability, hydrology, irrigation, water management, climate, transportation and logistics, precision agriculture, mountain ecosystem and economics. In fact, mountain ecosystem, mountain system and economics, this theme was suggested by Delhi School of Economics, Professor Pankaj Kumar. He is in Dublin right now. He has conveyed his regards and wishes to all of you who are joining the session today. So Delhi School of Economics, they are actually working, they have deployed their students to conduct a case study on the mountain ecosystem in Manali region. And precision agriculture and farming, this particular topic was suggested and specific by one of our partners, Sher-e Kashmir Agricultural University of Science and Technology from Kashmir. In fact, as far as the national ranking the previous year, they were ranked 4th. Transportation and logistics, it is a very burning issue. And in fact, one thing that I missed from the mandates part is the way in which we promote the usage of open source software in geospatial technology in all of our activities. Very soon, India will be transitioning from the usage of conventional GPS systems to a more India-specific technology called NAVIC, navigation using Indian constellations. So NAVIC technology has been envisioned and developed by ISRO. It has already it is put in practice. In fact, most of the transport vehicles, container trucks and all those things, they have a module of NAVIC which is used for tracking. So both GPS and NAVIC, it runs parallelly in a compatible mode. Anyone who is interested in uploading submissions of on our Mapathons competition, if you use NAVIC, you will be getting extra brownie points, extra points from the organizing team. The crux is to make sure that all of us promote the usage of Indian satellite data and also indigenous Indian technology with Government of India. promotes and wants every citizen to adhere to. So this is a glimpse. This map portrays the presence of our interns across India. So the previous edition of Mapathon, the winners of which who were eligible and they applied for it, out of 1734 submissions, I think only 530 approximately were shortlisted to upload their SOPs. And out of that 500 odd statement of purposes that we received, our team, with the direction of Professor Pennan, we had shortlisted 50 interns finally. And this is the distribution of interns. And in fact, because of the special purpose vehicle option that we had given, we have good participation from Northeast, Jammu and Kashmir. And this year, I think from Lakshadweep, one of the participants is joining in this National Space Day event. So please do participate. And in case if there is any support you might require, we'll be happy to help. Coming to the National Geospatial Awards, please scan this QR code. You will be redirected to the FOSSEE website. If you think that you can apply for the awards, please do it. And in fact, we encourage every citizen of India who is belonging to any specific category, faculty, student, industry personnel, if you are a curriculum setter, everyone is invited to apply. So please scan this QR code to register for the National GIS Award. And in fact, from today, the nominations are open. So this is all I have from the FOSSEE GIS project. And once again, I would sincerely thank our principal investigator, Professor Kannan Moudgalya, Professor Pennan Channasamy, our co-principal investigator. And in fact, from Rudra team, I have my colleagues Manu Lakshmi and Mohan joining us. Yeah, so if both of you would like to come forward and share your opinion. Madhulika is here. Yeah, I'm sorry, Madhulika, I missed you. So my colleague Madhulika is also here. And there are some of the core Rudra team members who are engaged with some other activity. They are not able to join today. But I'm again thankful to Professor Pennan Channasamy for his generous support and guidance in making the geospatial vertical of the FOSSEE activity a grand success. All of our activities are not only open to engineering domain, it is open for every domain. Even art students can apply. In fact, in this year's submission, we have participation from history department. They are mapping culturally important places in a specific geography in Tamil Nadu. So sky is the limit. Please feel free to explore our website, apply for our activities. We are just a mail away. You just shoot a mail or just contact us on WhatsApp or social media. We'll be very much happy to support all of you. So once again, I sincerely thank all the institutions who have joined us online and also offline here. On behalf of the National Mission on Education through ICT, our funding agency, Ministry of Education, Government of India. I'm sincerely thankful to all of you. So this concludes my session. In case if you have any doubts, my email ID is here. It is mohammadqasim@iitb.ac.in. We'll be happy to interact after this session as well. Please do participate in our September 15th activity. It is much crucial and important. We also are planning to stream it online in case if our venue gets full. We have just 350 seats available in one of the auditoriums that we have booked for the September 15th event. If you are from any remote locality, feel free to get in touch with us. We will make sure that you also have the same experience of our activities there at your campus. So without taking much time, I would now like to invite Mr. Rajesh Koshalkar. He is the national coordinator for the open source hardware initiative of the FOSSEE project. He has been here with IIT Bombay for more than 20 years with various projects. And under Professor Kannan's guidance, he has developed some technology like Arduino on Cloud. They also have come up with Arduino on Books. So I welcome Mr. Rajesh Koshalkar and also his team, Pratik and Pratik, who have come here. So over to Mr. Rajesh.
Thank you, Kasim. I'll just set up the system first. Yeah. Hello. Thanks, Kasim. I would like to thank Professor Kannan, Professor Pennan also, and all my team members from FOSSEE and Spoken Tutorial. So my topic is right now launching into learning, Arduino, and the fundamentals of rocketry. So everybody must have light a rocket when they were kids, now also. So it's a basic chemistry and physics. But today's technology has really gone way beyond the simple physics and chemistry. Of course, that same technology is also used as a burning fuel and taking the rocket ups. But there are a lot of other things that I would like to point it, and learning is required for that too. So, I'd just like to point it, build your Arduino skill before exploring to rocketry. So why this is required, but why Arduino? That's the main question. So Arduino is a very small prototyping board, or you called it as a tinkering board. So where all the required things that is required to make a prototype are present. For example, if I want to connect any sensors, there are two types of sensors which are available: a digital sensor and analog sensors. So this can be connected to the Arduino, and a person can program in trying to get the data from that particular things. So there are various form factors available for the Arduino also, and depends on the usage of the people, students, they can opt for that particular Arduino. But Arduino Uno is one of the very basics, and to kickstart that thing, I feel Arduino Uno is the best available hardware where you can start off. Now, but there's again who are starting off how to know. People should have a basic knowledge of electronics also, and for that, I'd just like to take few of the things apart from my slide. So as Professor Kannan, everybody mentioned about the FOSSEE. So I basically take into Arduino only. So Arduino has got a lot of potentials for the future. So we have a lot of things like Arduino IoT with GIS, Arduino on Cloud, Circuit.js, ElectroBlocks, Jupyter Notebooks, OpenPLC, and all these things. So these are the various verticals under the Arduino what we have. So as I was talking about the basics of electronics, so you really require to know about the basics. So you can just try to understand with the simulation part with the Circuit.js. So Circuit.js is a simple simulation softwares which are available free, and one can try to make simple circuits using first is your connecting a Ohm's law. So it starts with the Ohm's law. One can see the resistance of lower resistance. There is a lot of current is flowing. So you can see in animated way how the current flow is having, and since the resistance is high, so there is less current is flowing. So same thing what we can do is if I increase the resistance value here, the moment I increase the value to 100K, you can see it is running very slow. So simple simulations, but there are a lot of circuits which are available that one can definitely try and use it for their simulation. So here you can build a circuit and also try to do the see the graphs, various graphs which are coming out. So one can learn the basic electronics from this particular part. Of course, your teaching, which is there at your schools and college levels, is required. Now, so this is where understanding the basic concept, you can just check it out. Now, part is where to learn the Arduino. So there are the platforms which are available. So we have built our own platform called as Arduino on Cloud. So you can just go to simulation.iitbx.in. So on that particular platform, you can learn Arduino. So this is a simulation mode of Arduino where a student, if they don't have Arduino with them, they can definitely learn Arduino from this particular website. So no hardware required. So no worries for the hardware and no worries for any burnings or anything like that. So it is a pure simulation mode. The students can just drag and drop the components, the controllers which are available, just drag and drop it. Okay, make the wire connections. And all this thing can be done with this part. And there are a lot of other components available, just like your motor is there, LED is there, buzzer is there, a lot of things are there. I'll just give a small thing how the thing works. If I just consider a simple example. So this is a circuit which is made using various components which are available in this part. And here you can write the code here itself. After completing the code and your circuit is properly done, you can run the simulation. You can see it is running the simulation and it is working. Now this particular thing is whenever I'm trying to change the value in the potentiometer, the value will affect the rotation of your motor. So as you can see, as I'm rotating the potentiometer, this thing. So this is the simulation mode that students can definitely use it. And here there's no issue as such, any burning or miss connections or anything. Everything is going to be safe. So always prefer to run the things in the simulation mode, get the confidence, and then move out to the actual using the actual Uno kit, Arduino kits. Now, as this is my, again, a very standard slide which is available. So humans have got sensors. So what are the sensors? You got sight, you got hearing, touch, smell, and taste. Taste, or you can speak, is also one more part. So can anybody talk about the Arduino sense? What are the different Arduino sense for it? For seeing, so we have come up with the camera. Okay. For hearing, speakers are there. For touch, of course, touch sensors are there. Smell, there are sensors like gas sensors, various gas sensors are available, which can be integrated. And voice, of course, to listen to the voice, mic is there. And the taste. So for taste, there are sensors available, but the development is still going on. Our biotech engineers are still working hard of it, and definitely one day will come so that some of the test sensor will also be out. Yeah. So why I'm talking for all these things? Basically, Arduino is a device where you can connect all these sensors to it and try to make it. Now, as I was talking for the human sense, now with all the sense which are available, a humanoid can be built up. Okay, having the basic sense and all this. Of course, the artificial intelligence and all this thing will definitely come in, but it really requires a lot of processing, and that time Arduino won't be able to process all that. But at least the basic part of the things can be taken. Now, there are few sensors which are available like gyroscope, magnetic and stabilizers, and communications which are there. So communications that you can see today's, sorry, I'll just take to the gyroscope. So gyroscope is one of the very good thing that is available, especially for the rocket technologies, where whenever the rocket moves, it's try to stabilize itself with the gyroscopes. So whenever it moves in the x-axis, it try to make some threshold values and try to come in with a proper angle, whatever he has to go. So there is a magnetic and stabilizing circuits or sensors also available. Communication, so rocket has to continuously communicate with the ground stations. So it's not only rocket, any sensing devices and all those things, it always requires to communicate with the other devices. So in rockets, it has to continuously communicate with the ground station for many, from launching till stationary, and after it is going in the stationary mode, and a lot of data, which is now after that it is going to transmit, is through the communication channels only. So this is something called as CubeSat, which is again, there are a lot of based, the CubeSat is basically, it started with ArduSat. So ArduSat is Arduino satellite. So it's a small cube. What is cube stands? It's a 4 inch by 4 inch or 10 centimeter, 10 centimeter cube is there. So this cube is basically called as 1U cube, 1 unit. And in this particular small cube, lot of Arduino plus sensors and all these things are available. So you must have heard about the ISRO has launched around 104 satellites few years back. So these are all nano satellites. So one of the examples are cube satellites. So this is very small things which are going up. Recently, one of the students from Tamil Nadu also has developed the cube satellites, which he named after Dr. Kalam, called as KalamSat. So the second version of KalamSat was launched by the ISRO. Initially, it was first was launched by the NASA, but the second was launched by the ISRO itself. Again, these are all LEO satellites. So LEO stands for lower Earth orbits, basically. So and this particular things, I'll just show you. Yeah, the cube satellites, I've already talked about the cubes and all this stuff, the 1U cubes, but it goes for more units also to become a bigger sets. So it's more like a stacking the devices. So I have a communication stack of one U, I can have a sensor stack of other, and so that you can make a bigger stack of it. And again, I'll just go further for this part. So we have the largest, our Mount Everest. So you have a place where only the clouds run, commercial airlines runs. So meteorites and all this thing come in this part. So you have lower orbit satellites. So these are the satellites where all these kind of satellites generally stay. And there is one more thing which is coming to India, but it is very much there in US. It's called as Starlink. So Starlink they are all lower orbit satellites. So which is widely used for communication. And most probably in future, we will not have most of the towers, like what we have with the mobile towers and all this thing. It will go, and everything communication will be done through this kind of stuff only. Above that, you have the international spatial, GPS, and traditional satellites. Above traditional satellites, it's free space. Yeah. So now this is more of a technical part. I'd also like to point to in learning of Arduino. So already I've talked about one can learn Arduino with the simulation software. If you already have the hardwares and all this thing, and one can also learn Arduino using the spoken tutorials, which are also available in various languages. It is already dubbed in Hindi, Bangla, and other stuff. I'll just take it to, so in English. I think some net issue is there. So in this tutorials, we talked about from the very basics of Arduino and recognizing various electronic components. Then how to install Arduino IDE, and writing your first program. So this is the first program, like Hello World is there majorly for the computers, and for the first program for LED, Arduino or any hardware devices, blink of LED. Yeah, so that you are going to learn, and after that there is a series of how to connect various components and to see the output. And at the end, we are coming basic. After completing the basics of Arduino, we are just dividing into two parts, is IoT and one is for robotics. So these are two different things. So one can just concentrate on robotics and build more on the robots, and one is the IoT. Of course, this can be merged further also for IoT related activities, but we thought of just make it separate, but definitely the student can take it further and assemble it also. So we have got the IoT devices. So introduction to IoT. How a simple, here we have talked about how a simple weather station is to be made, and how the temperature and humidity data is transferred to a cloud where the IoT platform is available, and how to do the analysis after that. So we have after that we have assembling a robot and controlling a robot using Bluetooth. We also have further advanced topic, which is for how to run the assembly program using the Arduino. Now, rocket is a very small thing, whatever goes up. So it's not only that engineers are required or anything. So there is an art, or somebody is very good in origami is also required. So this is a simple example. It is plugged, everything is put it in a very small tube. The moment it goes in the space, it expands in a very big thing. So this is generally an example of a star shade. So what is a star shade? So star shade is basically, everybody must have experienced it whenever a plane is going above and a sunlight is coming. So you generally try to block the sun and see the plane very clearly. So if a star, sun is there, I'm trying to see the Mercury or Venus planet or something like that. I want to block that star, so that I can see other things which are coming near or anything blue. So these are majorly star shaped to block bright objects. Now, this can be this simple origami, paper done. Yeah. So this is where this is done by the NASA JPL, and the similar things can be used. You must have seen whatever we have on the Chandrayaan and all these things. They are folding antennas, and these things. Same thing. Many of the satellites uses this part. You must have seen about the James Webb telescopes also. So these are simple examples where it is just from the small tube, it comes out and becomes a big satellite, so that the antenna because all these satellites should be self-powered. So taking the solar cells, everything, and capturing the data also, antennas, everything is so jam-packed. The rocket is very big, but all these things is just on the head of it. The rest is only the fuel part which is going to take him up. So this is more about all about the rockets and how one can learn about. So here, as you can see, it is opening the part, the things. So here it's pure electromechanical things. This is where student can learn how Arduino and all this thing can be used to operate this particular mechanical devices. This is all programmed and through sensors only. Now I'll just come to the very small topic. Many people are okay with trying to do, but there are some people who are just stargazing, like to view the stars, where is the planet here, and all these steps are there. So there are a lot of clubs who generally do it, and there's a very good software called as Stellarium, so which is used for the stargazing. So Stellarium gives you, if you are having your location mapped with it, it will give your present sky status. And today this is my say. So here my various stars are there. Here's the Jupiter planet is there, and all this thing. It will show you. And with the help of the green laser, generally the stargazer generally use this particular pointers, to show it, because green laser is the only thing what can be seen directly at night. Your red laser is pointer, so whenever it hits, it shows you the point. But green laser, you can see the beam which is going out. So I'll just end up my talk with this word. May the Arduino be with you. So I'm a big fan of Star Wars. That's why I use a lot of words from this one. Thank you. And I would like to present a small video which is designed by using Arduino, and it's a 3D printed. So you can just see the various things what we can design part using Arduino. So it's a 3D printed rocket. As I'm talking about, there's stacks, so which are different stacks. You can stack it for the controllers and communications, and of course the sensors. I'll just skip few of the things. These are all 3D printing process going on. All the 3D printers, so it's not that black point, it's interdisciplinary. A lot of mechanical students also comes in, and electronic students also comes in. Of course, other parts from the physics and chemistry people also comes in. So these are the rudders where actually you can design the thing, where direction, as I was talking about. So with the gyroscope, I can design it. If it is tilting, I can just rudder, I can just make it straight again. These are all inputs are given by the sensors. this is purely 3D and using Arduino software and those small microcontrollers. Now one can see there's a camera on the top, and here's a marking. So whenever he is moving the marker, it is following. The camera is following. So you can see the missile technologies and all the things. So it has to hit that, but if the object is moving, also it will follow that part. So this is how things are done. So you require a feedback mechanism. So all these sensors, what is going to give? Camera, the gyroscopes, and all these things are a feedback mechanism to guide the rockets and all this stuff. So that's all from my side. Thank you. Yeah. I forgot to talk about because Kasim mentioned about Navik. So this is a Navik module. It's such a small module which is available, and one can try to connect with Arduino and try to get a location. It just required 2 pins of Arduino, and the Indian satellite Navik system works on L5 band. So it is GNSS. So nowadays you have this GNSS available on your mobile devices also. And Indian satellite basically use L5 band for their thing. And many of the vehicles, especially the higher, mid or higher range vehicles, are by default coming up with this geolocation devices built in. Okay. So they uses this Navik, not Navik, they uses this IoT chips like for data communication. Yeah, thank you. I would like to invite my 2 of my colleagues, Pratik Bhosle and Pratik Nimane. And so they have really helped up doing this part a lot. Yeah, thanks a lot. Yeah.
Morning.
Yeah, so now we are nearing towards the end. But before that, I would like to welcome the mentors from the Rudra Lab. So with Professor Pennant's permission, I would request Manulakshmi, Mohan Sarkar, and Madhulika to join us on stage. Please come. Yeah, so you can share your experience about your association with the FOSSEE project through Rudra, and if you have.
Thank you, Professor Pennan sir, for giving the opportunity. So I was an intern for this FOSSEE Mapathon project, and I mentored 3 students. So they were all from University of Central University of Karnataka, and they were doing geoinformatics. So they came with their own interest. So one came with coastal erosion after cyclone, and that was in Odisha. Then another one was she was working on health issues and resource distribution or distribution of resources related to health in West Bengal. And another one was climate change issues and water resource distribution is one of the district in West Bengal. So it was nice experience to work with them since there was a lot of interactions with them, talking with them. And since they are having new experiences with the same, so I was also lucky enough to interact with them. Thank you.
Hi, good afternoon, everyone. Thank you so much for the opportunity, Professor Penn and Kasim. I am Manu Lakshmi Yadav. I am a third-year PhD student under Professor Penn. My PhD work focus on gender and groundwater management, and I have been very fortunate to get these students also from the FOSSEE team whose problem statement also revolves around the same gender issues. So they came up first with the problem statement. As a mentor, I have helped them into refining and finalizing their problem statements. So in which is inclined towards the research part of it. Also, when they come up with the queries like the data downloading or how to map it, or as sir was also mentioning, how to index it, or using basic GIS, who all are not equipped enough, skilled enough. So I also, this was a two-way process. I also got to learn a lot from the students as the research area was resonating with them. Also, the writing part is also there after we submit the report, as was shown earlier into the presentation. So that is also one of the very good things that I will recommend, because writing is also very important while you are finishing up the project. So the feedback while finishing it up, how to write it up, how to present it in a presentable manner so as to get the good results out of it, was also told and instructed to them. That was, again, as I've mentioned, it was a two-way process, and I've also got to learn a lot from them. And I'm looking forward for more and more participation during the current cycle that is going on. Thank you so much.
So we have two video clips received from one from Colonel Kailash Chandra Tiwari. He is the head of the Department of Civil Engineering at Delhi Technological University. In fact, he is the one who is instrumental in bringing geospatial technology or geospatial science as part of the GATE exam curriculum. So he has sent us a recorded message. We have another video bite received from a faculty from University of Ladakh, Dr. Vani Shuhail. So in fact, he is one among the mentors who has trained our interns. In fact, we have two interns from Ladakh, Tashi Gyatso. He is properly from Leh. And we have another Ladakh from Kargil. Her name is Ms. Razia Banu. We have never seen both of them. We have never interacted with both of them. But world-class quality submissions, world-class maps based on the geography of Ladakh, those people have worked on. So we will be playing it. But before that, I would like to invite our managers, Mrs. Usha Vishwanathan. In fact, she is always behind the show. So she is the one who coordinates the overall activities of FOSSEE. And in fact, in specific, she takes care of the R activity along with other tools that the FOSSEE project promotes. I would like to introduce and welcome Mrs. Payal Mukherjee. She's again sitting in the last row. So I request both of you to please come forward. Mrs. Payal is in charge of the Open4 initiative of the FOSSEE project. In fact, we learn about computational fluid dynamics and all those things. How many of you like cars? All luxury cars, Ferrari, Lamborghini. Kisko nahi pasand? Everyone likes, right? So how many of you would like to become future scientists, and how many of you would like to specifically work in nuclear reactors if you get a chance to? So there is a tool called OpenFOAM, which we promote from IIT Bombay. It is used by industry. In fact, industries like Volkswagen, Tata Motors, and so they promote. In fact, the secret thing is it is not only available for the engineering domain, but students who are pursuing mathematics course. In fact, they have a paper called fluid dynamics. Most of them have it as an elective, but we from the FOSSEE project are here to give the computational aspect of the fluid dynamics through the open form project. We have case studies and a lot of activities. So can you turn the camera towards her? So she is Mrs. Payal Mukherjee, who is in charge of it. So both of them are very much instrumental, and they support us with all the activities. There are other managers from the FOSSEE project who have joined us online, and so possibly we can get everyone together during the National Teachers Day celebration on September 5th. So this is all from our side, and I would request our eStudio team. Yeah, in fact, I'm sorry, I forgot. Deepak, Pradeep, and Kailash. So they they are instrumental in you seeing us live. So I request Deepak to play the video of Colonel Kailash Tiwari first, and then Dr. Sohail, who have sent greetings from their end for this National Space Day celebration.
Good morning, everyone. First of all, I express greetings and compliments on National Space Day on behalf of the Honorable Vice Chancellor, the entire faculty, and the researchers and the students of Delhi Technological University, Delhi. I also express my gratitude towards FOSSEE IIT Bombay for giving me a platform to express my sentiments and views on this special day. As you all know, that this day is being celebrated to commemorate the first successful landing of Chandrayaan lander on the southern pole of the moon, a first of its kind for the entire humanity. I am confident that this is a humble beginning which will transform the way we perceive the entire planetary system and encourage far-reaching research in this domain. Let me also take this opportunity to share with you some of the initiatives at Delhi Technological University which we are pursuing with a lot of dedication and commitment. The university established a multidisciplinary center for geoinformatics in 2019 to make its contribution towards this emerging field. Initially, we started with capacity building with a PhD in geoinformatics program with an MTech, AICT sponsored MTech program in geoinformatics and several short-term courses which we conducted during the COVID period. One of the major milestones of the center has been introduction of geometrics in GATE exam with effect from 2022. We are continuously working with UGC to get this subject included in NET exam and we are also trying to initiate a separate cadre for students who are working in this field. Department of Science and Technology envisions development of geospatial ecosystem in 3 stages. First, the school education, followed by college education, and then startup and the industry ecosystem. DST also wants to develop both the geospatial science and the geospatial technology parallelly. Keeping this in view, DTU has also launched a MSc program in geospatial science with effect from 2024-25. DTU has also approved in principle establishment of a Department of Geospatial Science and Technology with effect from next academic year. Once established, this will be the first Department of Geospatial Science and Technology anywhere in India. Thereafter, we also propose to launch 2 integrated programs, BSc MSc program as well as one BTech MTech program in geospatial technology. We are committed towards developing this field as an emerging field. The nation needs to steer itself much ahead of other countries in the globe. Once again, my compliments to all on the National Space Day. May we take the humanity where no one has ever reached. Thank you all very much and Jai Hind.
Good day to everyone. I, Dr. Vani Suhail Ahmed, Assistant Professor, Department of Geography, University of Ladakh, wish to express heartfelt greetings and warmest compliments to FOSI, IIT Bombay, on behalf of Honorable Vice Chancellor, Professor S.K. Mehta, In charge Administration, Kargil Campus, Dr. Mehboob Ali, Coordinator, Department of Geography, Dr. Mohammed Taqi, and from entire faculty and students of University of Ladakh on occasion of this National Geospatial Day. Today, we come together not to celebrate just a calendar day, but a monumental achievement in human history. The successful landing of Chandrayaan on the south pole of the moon. This extraordinary feat, the first of its kind for humanity, marks a new chapter in space exploration, illuminating the path forward for generations to come. As we reflect on this historical achievement, I am proud to share the strides made by University of Ladakh, a very young institution established in 2019. Though in its infancy stage, our university has embarked on a journey of rapid academic and research growth, fueled by a passion for excellence and innovation. The establishment of Department of Geography is a testament to our commitment to geospatial sciences. Our state-of-the-art remote sensing and digital image processing lab serves as a hub for cutting-edge research and education, preparing students to be leaders in this dynamic field. In recognition to the importance of these geospatial technologies, the University of Ladakh has recently introduced certificate courses in remote sensing, digital image processing, GIS, and GPS. These programs are designed to decorate our students with the skill and knowledge necessary to thrive in an increasingly interconnected and technological world. As we celebrate National Geospatial Day, let us not only honor the achievements of our past, but also look forward to the possibilities of the future. Together, we can harness the power of geospatial technologies to address the challenges of present and create a better world for all of us. Once again, I extend my heartfelt compliments to FOSI, IIT Bombay, for their visionary leadership in promoting geospatial awareness. University of Ladakh stands ready to collaborate and contribute to the exciting field of geospatial technologies, and we look forward to many fruitful partnerships in the years ahead.
So I now welcome Mrs. Payal Mukherjee to talk about today's open forum event, which is happening in the afternoon.
So much, Kasim. So as Kasim mentioned, I look after the open form, CFD open form category of FOSSI. And today afternoon, we are having a very interesting session as on how to learn open form and how to augment that knowledge till advanced levels. Okay, so please join us in the same YouTube link at 3:30 today afternoon. 3:30 to 5:30 will be live on the same YouTube link. So whoever is interested are welcome to join us. Thank you.
Good afternoon, all. Thank you for joining us on this wonderful day. Today, we are celebrating the National Space Day, and I'm very happy to welcome, thank you all for attending this event and making this a grand success. I also like to thank all the students and faculty members who are present here, as well as who has joined us online. And I will especially thank the faculty members who have encouraged their students to join this session. And we hope that the students as well as the faculty members will benefit from this event. And as you are now aware that we are having two events which are going on. One is the Mapathon and another is the IoT Hackathon. So do participate in those events and get all the benefits from those. And now I will like to thank Professor Kannan Moudgalya, who is the principal investigator of this project, which is a FOSSEE project, and Professor Pennan Chinnaswamy, who is the PI, co-PI, who is taking lead in the geospatial activities of FOSSEE. So thank you, sir. And I will also like to thank all the staff members of FOSSEE who actually has supported this event, and especially Kasim, who has coordinated this event wonderfully. And last, I would like to thank the funding agency for this project, which is the National Mission on Education through ICT, which is supported by Ministry of Education. And they have been instrumental in supporting us for the past decade. More than a decade now, this project is going on. So thank you for the funding agency. And it was a great day, and I thank you all.